In a Volkswagen assembly plant in Portugal, there's a small plastic ring that fits over the wheel hub during assembly. It guides a pneumatic lug nut gun into the right position so that the tool doesn't scratch the finished wheel surface. That's it. That's the whole part. A simple protective jig. Now, it used to cost 800 euros and it took 56 days to produce. Today, they just 3D print it in-house for about 21 euros. The lead time is approximately 10 days, and of course, the part itself probably takes a few hours to print. It's got the same function, the same performance, and it costs 97% less money. Now, nobody buys that jig. It never leaves the factory, but it directly controls whether every single wheel that rolls off that line looks perfect or gets sent back. And that tells you everything you need to know about where the real money in 3D printing actually is. It's in the tools that make the products. At Vision Miner, we've spent nearly a decade helping businesses 3D print production tooling in real engineering materials. Ultim, PPSU, polycarbonate, nylon, you name it. Jigs, fixtures, drill guides, assembly aids, we see it every single day. Our 22 IDEX was designed with exactly this kind of work in mind. Carbon fiber nylon all the way up to PEEK and PEC. And tooling is one of the most common and definitely most profitable applications across our entire customer base. So today, I want to break down exactly why that is. Every single factory, cars, airplanes, medical devices, electronics, they rely on a huge number of small, specialized tools that most people never see. Jigs, fixtures, drill guides, alignment plates, work holding nests, welding fixtures, that's a big one, inspection gauges. These are all what makes the final product possible, accurate, and repeatable at scale. If you're drilling a hole through a composite panel on an airplane, then you don't eyeball it. You use a drill guide that locks onto the panel and tells the drill bit exactly where to go. If you're welding a pipe at a specific angle, then you use a fixture that locks that pipe into the correct position every single time. These tools enforce precision. They take the variability out of human hands. They do it across thousands of production cycles. So when a jig is even slightly better, whether it's better alignment or better ergonomics or faster setup, then that improvement multiplies across every single part that flows through it. A fixture that saves 5 seconds per cycle doesn't sound like a lot, but if you run that across 10,000 cycles, you've saved almost 14 hours in labor. Traditionally, if you need a custom jig, here's what happens. You design it in CAD, you send it to a machine shop, and then they'll quote it and they'll schedule it in their production, and then they'll huck it out of an aluminum block and then ship it back to you. You'll go and test it on the floor, and usually something needs to change, almost always actually. So you start that whole cycle over again. That usually takes anywhere from 1 to 6 weeks minimum. And the constraint isn't the part itself. Most jigs and fixtures are actually very geometrically simple, but the outsource, machine, ship, validate, revise, that whole cycle, every single step adds time. Every handoff introduces delay. Meanwhile, your production floor is waiting. The tooling becomes the bottleneck. Not because the tools are hard to make, but because the system for making them is slow and expensive and inflexible. Now, this is exactly what we help companies solve here at Vision Miner. Custom tooling printed in-house in hours in real engineering materials. The build volume on the 22 IDEX is comparable to a Stratasys Fortis, which is one of the main machines that companies have been using for this kind of work, except the 22 IDEX is a fraction of the cost. And there's no service contracts, there's no RFID locked material cartridges, there's no proprietary slicers that you can't control. You can use open materials from any manufacturer that you can find filament from. And the 22, it prints ABS, ASA, nylon, PLA, polycarbonate, and it goes all the way up to Ultim 9085, PEC, PEEK, and other high performance, high temperature materials. That entire range of engineering polymers in one engineering platform, one open platform. Now, we already talked about Volkswagen, 800 euros down to 21, 56 days down to 10. But here's what makes that example really interesting. The printed jig could be iterated based on operator feedback. So if a worker said, this grip is kind of awkward, then the engineers just redesigned it and reprinted it, and they had an improved version on the floor the next day. Now that doesn't happen when your tooling takes 2 months to produce. Now let's talk about Boom Supersonic. When they were building the XB1 demonstrator jet, Boom printed over 700 drill guides and tooling components. They used Ultim 9085 and carbon fiber reinforced nylon 12. Now each drill guide encoded the exact hole positions into the geometry. The operators didn't measure, they didn't mark anything, they just placed the guide and drilled. Traditionally, each tool would have cost thousands of dollars and taken weeks. Boom printed them overnight. But the bigger win was actually speed. The tooling evolved alongside the aircraft design, and when the design changed, the tools changed right with it. And then there's Zeiss, the optics company. They're using 3D printed alignment tools and assembly aids in serial production of their optical components to make incredible glass for cameras and all sorts of stuff. Tooling costs ended up dropping from 300 euros per unit down to 20 euros. The weeks went down to days. And Boeing worked with Oak Ridge National Lab, and they 3D printed a full-scale trim and drill tool for the 777X wing using carbon fiber reinforced ABS composite. They printed it in about 30 hours, and that project, back when it happened, actually set a Guinness World Record for the largest solid 3D printed object at the time. Now, most jigs and fixtures are nowhere near that size. The vast majority fit comfortably within the build volume of the 22 IDEX. You don't need a massive system to start printing tooling that impacts your bottom line. Tooling is, hands down, the easiest and fastest path to return on investment with a 3D printer. I tell people this all the time. Firstly, tooling doesn't need the same certification that a lot of end-use parts do. You design it, you print it, and you put it onto the floor, and it starts working. The barrier to deployment is dramatically lower. Secondly, the economics are immediate. If you're outsourcing a fixture for $500 in 6 weeks and you can print it for $30 overnight, that's money straight back into your pocket on day one. Thirdly, the improvements compound. Because iterating costs almost nothing, you actually fix problems that you'd probably never bother fixing with traditional tooling. A fixture that costs $20 to reprint, you're going to optimize it 3 times before lunch. That's a fundamentally different relationship with your production tooling. At Vision Miner, this is one of my favorite conversations to have with customers because tooling is where additive really proves itself the fastest. You don't need to rethink your entire production system. You just start printing the tools that support the work that you're already doing. Now, a lot of companies have been doing this on Stratasys Fortis machines, and those are solid printers, but they come with price tags well over $100K. And sometimes, a lot of the times, they're pushing past $250,000. Service contracts are technically optional, but if something breaks on a $150,000 machine without one, you're paying per incident repair rates with no guarantee on timeline.